Consider the following matrices, and here we are given a matrix A and a matrix B, and we are asked to use the definition of the product to find matrix A times matrix B, and then to find matrix B times matrix A. So here we go. Part A. We want to find the product, matrix A times matrix B. Now, before we even get started, we want to make sure that the number of columns of matrix A equals the number of columns of matrix B. So let's check. So we know that we have matrix A here, which is a 3 by 2 matrix. And then we have a matrix B, which is a 2 by 2 matrix. So in checking, the number of columns of the first matrix matches the number of columns of the second matrix. Woohoo! So we know that matrix A times matrix B exists. We can also see the size of this new matrix. So we can also conclude that therefore the matrix defined as AB is or will be a 3 by 2 matrix. Now we want to be mindful here that this question is specifically asking us to use the definition of the product. So we want to be sure to use the formal definition here for good practice. So keeping the sizes of these matrices in mind, let's recall the definition. So by definition of the product, matrix A times matrix B, we're going to leave matrix A as it is, but let's rewrite matrix B in terms of its column vectors. So we have two column vectors here, vector B sub 1 and vector B sub 2. And by definition, the new matrix will have column vectors defined as matrix A times vector B sub 1, and the second column vector will be matrix A times vector B sub 2. So that's what we need to do here. Let's find each one of these column vectors. So first we need to find matrix A times vector B sub 1. So matrix A is given to us. We have -2, 3, 5, 4, 3, -2. And this is multiplied by the first column of matrix B, 4 minus 3. So by definition, we can expand this to a linear combination. So that's going to be 4 multiplied by the column vector -2, 3, 5, plus -3 multiplied by the second column vector 4, 3, minus 2. So by vector scalar multiples, we can rewrite this as, we have 4 times -2 is -8, 4 times 3 is 12, and 4 times 5 is 20. Plus, we have -3 times 4 is -12, -3 times 3 is -9, -3 times -2 is 6. Which leaves us with a beautiful final answer of -20, 3, 26. So here is the first column vector of our new matrix. And we want to apply the same idea to find the second column. So our second column is matrix A times vector B sub 2. So again, we have matrix A, which is defined as -2, 3, 5, 4, 3, -2, and we're multiplying by the second column of matrix B, which is -2, 3. So by definition, this is -2 multiplied by the first column, -2, 3, 5, plus 3 multiplied by the second column, 4, 3, minus 2. And this is leaving us with, we have 4 minus 6, -10 as the first column. And we want to add this column to 12, 9, minus 6. So here we go. We have 4 plus 12 is 16, -6 plus 9 is 3, and -10 minus 6 is -16. And we're ready to state our final answer. We can say that therefore matrix A times matrix B, which by definition we have found using the product of these matrix and two vectors, And our beautiful final answer here is negative 23, 26, and the second column is 16, 3 minus 16. And so this again is our beautiful final answer for part A, using the definition of the product. But we're not done yet. We've got one more to go. We want to now go ahead and find the product of matrix B times matrix A. So in part B, we want to find B times A. And now again, before we even get started, let's check the sizes. So we have a matrix B given to us as a 2 by 2 matrix. And we have a matrix A, which is given to us as a 3 by 2 matrix. And in order for this product to exist, the number of columns of matrix B must be equal to the number of rows of matrix A. So do the number of columns of matrix B match the number of rows of matrix A? No! 2 does not equal 3, ever. So therefore, the product, or the matrix defined as the product B times A, does not exist. It's undefined. And that's it. If the number of columns of the first matrix do not match the number of rows of the second matrix, matrix multiplication cannot be performed.